Hi fellas, this is Chemaddicts again to the solution. Well, the things that we are going to study today are given below, okay? So here we'll learn about what is the main thing that we are going to learn today is what is cracking and reforming, what are main differences of cracking and reforming, some examples of them, how to identify them in the question. Okay, so let's get started. Wow, Buffett. Wow, Buffett. I've been recently watching Pokemon Go in the video tutorial, in the YouTube video. Really sorry for that. Okay. So let's get back to the question. Let's get back to the topic. Okay. So first of all, we will know what is meant by cracking. What is meant by cracking? So cracking is basically means splitting up. Cracking in organic chemistry basically means splitting up or forming small chain or forming smaller chain. These have the similar meaning, forming smaller chain. Alright. So cracking is basically is splitting up a bigger molecule into small cute molecule. Okay. Just like uh, um, breaking down decane into smaller octane useful molecules like octane, diesel, just like that. So now let us know the importance of cracking. Since there is a high demand for lighter fractions, since there is a higher demand for lighter fractions, since there is a higher demand for lighter fractions, okay, so we need to perform this cracking. So the heavier fractions here it means the heavier fractions are broken down into lighter fractions. Heavier fractions, heavier fractions, heavier fractions are being broken down into, this is mean. Sorry for my bad handwriting. Okay, I know my handwriting really sucks, as well as my English. Okay, since English is not my native language, really sorry for that. I'm trying my level best to make you understand, fellas. Heavier fractions are being broken down into lighter fractions. Okay, so long chains hydrocarbons are broken down into smaller fractions. These smaller fractions are more useful. Hydrocarbon fueled by large molecules. These smaller fractions are more useful. Okay, these smaller fractions are more useful. These smaller fractions are more more useful than large larger molecules. I mean, larger molecules are dumb. They are dumb. They are good for nothing. Man, man, they are good for nothing. They can't do anything. They are useless. Larger molecules are useless. Smaller molecules, smaller fractions are useful. They are intelligent. They can do. They're smart. They're smarter than larger molecules. That's why we need more smaller molecules. So we are breaking down larger molecules. Okay, larger molecules are good for nothing. That's why I am also good for nothing. Okay, so this is the importance for crude oil. So crude oil basic, sorry, not crude oil, cracking. This is the importance for cracking. Why we do, why do we carry out cracking? This is the main reason for that. So we will move on to the we will move on to the explanation for reforming. We will discuss the examples of cracking and reforming later on this video tutorial. Okay, so now let us discuss. Did I miss anything? Well, no, I hope not. Well, let us now talk about reforming. What is meant by reforming? Reforming means simply means let me see. Okay, reforming simply means modifying a structure, modifying a molecule, modifying a molecule. Okay, just like we modify many cars, you will see many cars. They sound a lot boom boom, just like that. I hope that you have seen many racing movies, just like Fast and Furious. By the way, I love Paul Walker. I really miss him. Okay, so I honestly I'm saying that I'm really missing Paul Walker. Paul Walker was a legend. Okay, so let us see. So we will modify a molecule just like uh, just like car racing cars. Okay, to look more cool. To look more cool. Okay. So let's see how do let's see the importance for reforming. The importance for reforming's importance. Okay, I know that you guys have a lot of importance in my life. Okay, so you are the main inspiration for me to make video tutorial. Without you, it wouldn't be possible for me to carry on. Okay, last time I have totally given up. That's why I had disappeared. So without you guys, it wouldn't be possible for me to carry on. So basically, you are my inspiration. So that is the importance of you fellas. Okay, now we are going to discuss the importance of reforming. Okay, so uh, we know that we need a lot of energy. That is why we do burning. Okay, so we get energy from burning. We get energy from the burning. So our main objective is to get most is to get most of the energy from burning fuel. Okay, so our main objective is to get most of the energy from burning fuel. Of course, we don't want to lose any money. Okay, so we want most energy from burning fuel, and that is the reason why we burn fuel. Okay, so how do we get most of the energy? We will get most energy sorry most energy from smooth combustion. I know what is meant by, I know you guys know the meaning of combustion. Combustion is basically mean burning. The other meaning of burning is combustion. The other word for burning is combustion. Smooth, from smoother combustion. Okay, so from smoother combustion, we get most energy. Okay, so our main intention would be to perform the smoother combustion. Our main intention would be to perform smoother combustion. The more smoother the combustion would be, the more efficient the engine would be. Okay, so for this reason we do reforming. Okay, now we know the importance for reforming. Now let us move on to the question, what is reforming? Okay, so now we will going to know what is reforming. So what is reforming? So reforming is basically, modification of the of the structure. It is simply the modification of structure. Okay, so let us look at deep. It is the conversion of straight chain hydrocarbons hydrocarbons it is the conversion of straight chain hydrocarbons. It is the conversion of straight chain hydrocarbons into branched chain, or else I can say cyclic or closed chain hydrocarbons. Okay, close chain hydrocarbons or arenes. Close chain hydrocarbons and arenes are the same thing. You guys all know. It is the conversion of straight chain hydrocarbons into branch chain or close chain hydrocarbons, okay, or arenes. So from here we get hydrogen as the byproduct. So the byproduct of closed chain reforming is byproduct of closed chain reforming is hydrogen. Okay, all right. Wow, perfect. So that's it. That is the importance and the meaning of reforming. Okay, so let us move on to some examples of reforming and cracking. All right. So now let us move on to the examples. Some examples. Cracking. Okay, guys, I will give you some free courses after the end of this tutorial. So stay hooked. Okay, guys. I hope that you will hook till the end of this video tutorial. Because I know that you love me very much. Okay. Okay. So now we are going to crack Decan C10H20. So Decan is an alkane which has 10 carbon atoms. Okay. So we are going to crack this C8H18 plus C2H4. So this is octane and this is butane. So this is a type of cracking equation. So here we have undergo the cracking of decans. Okay, we have cracked decane into octane and ethane. We can crack a decane in other way around, but this is one example. Okay, so from here we have learned the cracking, how to crack a big molecule into smaller chain molecule. So by the way, the examiner will ask typical question like this. The examiner, in most of the past question paper, you will see that the examiner has asked to write the cracking equation of some molecules, like some bigger molecules which has the carbon number 12, 20 into smaller molecules, just like this. Excuse me. So the examiner asks us to find the missing molecule. For example, the examiner asked us to find the molecular formula of ethene from this molecule, or molecular formula of octane from this molecule. So I hope that you can find that up by simply subtracting from the molecule. Suppose we are going to find ethene from here. So how am I supposed to find the molecular formula of ethene? Just like this. Just subtracting C10 with C8 and H22 and H18 respectively. Okay, so that's how we are going to do the cracking equation, and that's how you are going to deal with this type of questions. These are very easy questions and you can do it, I believe. So let's move on to the equation for the examples for deforming. Okay, so how we are going to deal with reforming? Suppose we are going to reform this molecule hexane. We are going to reform hexane, reforming the society. We are going to reform the society like Batman. Takes whole day to write this up. It's totally boring. Alright. Okay. So this is the molecule hexane. 1, 2, 3, 4, 5, 6. Okay. Hexane. So now we are going to reform this straight chain molecule into, first we are going to convert this straight chain molecule into ring chain or closed chain molecule. So let's write this up. Let us write this up. Sorry. See. 1, 2, 3, 4, 5, 6. Here it is. So what we have done here, let's see. We have converted straight chain hexane. This is straight chain molecules into cyclic cyclic molecules or closed chain molecules. Okay. Closed chain. Okay, closed chain molecules. So this is how we are going to reform straight chain molecules into closed chain molecules. This is the equation, and from here we will get hydrogen as a byproduct. I have forget to write. We will get hydrogen as a byproduct. Since it has two less, since this cyclic, if you have if you calculate, you will get that these cyclic molecules will have two less hydrogen than straight chain molecules. That's why. Okay, we will get hydrogen gas as a byproduct. Hydrogen gas as byproduct. Okay, so that's the reforming. That's the reforming of straight chain molecules into cyclic closed chain molecules. So now we are going to reform straight chain molecules into branch chain. I hope that you can guess. Let me copy this up. Copycat. I'm calling myself a copycat. Well. Fact. Now we are going to reform the straight chain molecules into branch chain molecules. Well, let's see. So the branch chain. Where is my brush? Looks like I haven't brushed this morning. Brushed my teeth this morning. Looks like I haven't brushed my teeth this morning. Is it okay? Yeah. Looks like my English is getting better now. Thanks guys. Thanks for helping me out. So you can see that it's not really hard that much actually. Just give one branching here, take a molecule, take apart from here and put it here. That's it. So easy as that. Actually, reforming and um, cracking is easy, but some of the student gets confused. Okay, so that's how we reform a straight chain molecules into branch chain molecules.